Hi, everybody. We're taking a look today at inequalities and how we might be able to graph an inequality and what it might look like. So currently we're taking a look at this Desmos screen, and you can see I've typed in an inequality. It looks similar to what an equation would have looked like before, but you'll notice we've got this less than symbol or greater than symbol instead of the equal sign. So we're curious today about what that might look like if we were going to graph it. And Desmos is fantastic for that. Of course, I could just go ahead and click on these dots and we could see it. But I don't want to ruin the surprise just yet, because what we're going to try and do is we're going to try and actually use a Scratch program to create what these inequalities would look like first, and then we'll come back and we'll double check it in Desmos. So we'll be back here in a minute. I will show you what these actually do. I'll play around with it for a moment. But first, let's go into Scratch and let's see if we can actually create a program that will do this for us. So go into Google, just type in Scratch, be your very first link. And we'll go ahead and create a new file. Now, I apologize. Sometimes I go a little bit too fast when I'm going through the coding. If that's the case, just pause the video and back up a little bit, and you should be okay. Now, this is the blank screen. We're just getting started. There's a few things that we need to do to our program just to get it ready for what we need to create today. First thing I want you to do is go down here to backdrops in the bottom right-hand corner. And we need to add in a grid, because we're trying to graph an inequality, so we need to see the grid. There's three different ones, but I'd like you to pick this one right here. That's going to put some numbers on for us so we can see them. The next problem is we've got our normal cat in there, our sprite, and I don't really want a cat this time. I'm going to try and use a dot, because what I'm going to be trying to do is plot a whole bunch of points. And if we could use a circle for that, that'll look a little bit better in terms of plotting points. So again, down here in the bottom right, this time click on this one here where it says choose a sprite. And I really want a circle. So there's a few different options, but the one I like the best is this one right here called button number 1. It's just a nice green circle. I'm going to go ahead and click on that. That means I don't need the cat anymore. So I'm going to get rid of the cat. And this is a really big dot so far. So I don't really want my button to be quite that big. Let's go ahead and change the size. I'm going to make it pretty small. I'm going to bring it down all the way to size 6. So there's still a small little dot there. You can see it. But it's going to work a lot better for plotting points now. The one other thing we need just before we start creating the program is the pen tool will be something we need, because we're going to try and do that, a couple of functions from the pen tool this time. To add the pen tool in the bottom left-hand corner, click on this square, and then just click on this pen, and that'll add it to our list of coding options. We should be all set now. We've got everything that we need. So what we're going to try and do is we're going to try and create this set of points that we're going to graph on our screen. And I'm going to do that by randomly generating some points. I'll show you how to do that in just a second. To get the program started, let's go to events, and we use our when the green flag is clicked. And something else that's going to be really helpful for us, maybe not obvious, but go down to pen, and I'm going to slide this erase all block out. By having that, that's going to help us when we run the program several times. It's going to get rid of anything that we might have had before. Now, what I want to do is I want to try and generate a point, and gradually I'm going to generate a whole bunch of points. But first of all, can we just create some point that's going to show up on this grid, and I want to do it randomly. So there's an option down here in operators that's going to allow us to create a random number. We'll use that in a second. But before we do, we need to create some variables. So let's make a variable. And of course, we're trying to create a point, right? And a point has an x coordinate and a y coordinate. So I need an x variable, and I need another variable. I need a y variable. There we go. And those have shown up here in the top left. We can see them. Right underneath, still in the variables menu here, we have set variable to. And I need to set the x variable to something, and I need to set the y variable to something. And this is where the random number part comes in. So let's jump down here to where it says operators. And right here, it says pick random. Now this currently says pick a random number between 1 and 10. And that's not really what I want, because I want something that's going to fit on the grid. So if you take a look here, it actually shows us the furthest that it goes to the left. So x can go as far as minus 240 and as large as positive 240 in this particular grid. So let's change it. Pick a random number between minus 240 and positive 240. That's for our x value. And for our y coordinate, we want to do the same thing, but notice it's not a square grid, right? It goes a little bit further left and right than it goes up and down. So the lowest we can go for a y-coordinate is minus 180, and the highest we can go is positive 180. And what I want you to notice, if you go ahead and run the program now, is going to generate these random numbers for us. See that? And keep running it. It's going to give us more and more and more. Now, currently, our green dot is just sitting there, right? We haven't moved it. So I actually need to tell this point to move to a new spot. So if I wanted to move it to a new spot, that's back up here in motion. And I want to say, go to a particular location. And the location that I want it to go to is the x-coordinate and the y-coordinate. So this looks good so far. Go to, but I need to replace this 90 and this minus 75 with the x variable and the y variable. So let's do that. Let's click on variables down here, and we'll slide the x over, and we'll slide the y over. And I think if we run this now, our point should move. Let's give it a try. There we go. It's moving. What I'd really like to do is I'd really like to keep track of all of the different spots that it's gone. So right now it's moving and it's changing each time, but because of my erase all, everything's disappearing. That's good. The erase all is helpful. I mean, I could get rid of that. There's a better way to do it. And the way to do that is with the stamp function. If I go down here to pen, the second one down says stamp. And what the stamp does is basically just takes imagine taking that button and pushing it into the screen, and it stamps that picture in that spot. So now if I run this program a few times, of course, it's still erasing everything, but it is stamping it. And the way I can tell, this is going to help us in a minute. Down here it says show. I'm going to get rid of this. Take a look. I'm going to get rid of that. So now our dot's not going to show up anymore at the beginning, but it will later. Here we go. Now, what we're doing here is we're just creating one random dot. This isn't particularly exciting. What I want to do is I want to create a whole bunch of them. To do that, we can go into the control menu and we're going to create a loop. There's lots of different loops that we can do. So this one here says repeat 10 times. I don't want to do this just 10 times, though. I want to do this a lot. So I'm going to slide the forever over. Now take a look back at our program and think about what we want to happen over and over and over again. The erase all should happen at the beginning. But all of this stuff here, the pick a random number, go to that point, and then stamp. That's what I want to happen many, many, many times. So I'm going to put that inside the forever block. Now what should happen now is that we're just going to constantly create these random points and stamp them all over the page. So we should see tons of points appearing totally in random everywhere. That's what we're getting here. This is pretty good. I mean, we're getting a completely random scatter plot. If you've ever talked about correlations before, we see there's no correlation here. There's no pattern. Everything's just totally random. This is a really good start. We're actually really close to creating our whole program now. But remember what we were trying to do in the first place. I'm going to jump back to our Desmos calculator. We were trying to graph this inequality right here. So we don't want all of the points like we're seeing here. We only want the points that satisfy this criteria. X plus y has to be less than 50. So for example, if x was 10 and y was 20, 10 plus 20 is less than 50. That's a point that we should have on the graph. But if x was 100 and y was 5, that would be the point 100, 5, but that's bigger than 50, right? 105 is bigger than 50, so that shouldn't work. So we need to add in new criteria here that's going to say, hey, you know what? We should only actually stamp this point if it turns out that our x and our y value really adds to less than 50. This is a little bit of a tricky spot, but it's actually right here for us. We're going to use this if statement. I'm going to slide it out. So the if is called a decision structure. And what it does is it allows us to make a decision about particular variables. So if something happens, then do whatever comes next. So my if part, we want to say if x plus y really is less than 50, Then I want to graph the points, and I want to stamp those points on there. So to make that happen, we're going to go back to operators again. And you can see a few of them here that we're going to need. We're going to need this guy here for our x plus y. And we're also going to need, we said less than 50, didn't we? Which is this one. I'm going to slide this out as well. Notice the shapes. The shapes help a little bit. So this will fit here, whereas you'll notice this guy here does not. So I'm going to slide this in. We wanted to say, remember, x plus y less than 50. So I need to put my x variable and my y variable in those spots. So click on variables again, slide the x in, slide the y in. There we go. So this says, if x plus y really is less than 50, then what did we want it to do? Well, then we wanted it to do this part. Actually go to the point and stamp it. So we're definitely going to pick a random number each time. And then I need to slide this if right inside my forever loop. See that? I'm going to slide it right in. So over and over and over again, we're going to pick a random number, and then we're going to check to see if it really is less than 50. And if it is less than 50, we're going to stamp it. Ready? Let's give it a try. Let's run this program. And it might take a minute with these because, I mean, we're doing a lot of random numbers. But probably already you can see a pattern, right? There's a lot of numbers that aren't showing up anymore. We're getting a whole bunch of points that are showing up, but they're all down here in this bottom left-hand diagonal, I guess, right? I'm gonna let it run for another moment just so you can see it. But the more points we get on, it starts to become more and more obvious what's happening. And what I hope you can see is I hope you can kind of see this straight line that's being created right at the edge of those dots. Right at the edge of those dots, we have a straight line going down there. It's this perfectly straight diagonal. And what we're finding is that all of these points that are randomly being generated at the moment, they all satisfy this inequality. X plus y is less than 50. All of these points, every single green dot that you're seeing right now, satisfies this inequality. And of course, there's numbers that are missing just because we haven't generated them yet. But what I want you to recognize is that anything down in this bottom section is certainly going to work for this. X plus y is less than 50. Whereas anything up here, these numbers, they're definitely going to be bigger than 50. And so they wouldn't satisfy this inequality. Okay, I'm going to stop this for a minute and let's jump over to Desmos because I promised I was going to show you this. Here it is here, x plus y is less than 50. If I go ahead and click on that, we can see the graph. And I hope what you can see is that this picture looks really similar to this picture, right? We've got this diagonal line right here. And all of our dots are underneath it in this case. The way Desmos does that is it just shades it. And the reason it's shading it compared to our dots is because we've picked a lot of points, but we haven't picked all of them. This shading is saying that every single point, all of these x and y values underneath this dotted line all satisfy this particular inequality. Okay? Now, something else I want you to notice. This is showing a dotted line. That dotted line right there is that line, x plus y equals 50. Okay? So it's exactly that line. But it's dotted. It's dotted. And the reason it's dotted, or dashed, I guess, in this case, is because this is a strictly less than 50. What that means is that, say, this point right here, the point 50, 0, that point 50, 0 does not satisfy this inequality because 50 plus 0 is 50, and 50 is not less than 50. So there's a very slight difference here. Watch what happens if I change this. This is currently a less than symbol. If I change it to a less than or equals to, and in Desmos, by the way you type this, you just type the less than symbol. And then if you type an equals right after, it changes it and it puts that less than or equals to symbol. And now it's a solid line. See that? If I get rid of that again, dotted line for a less than, and a solid line if it's a less than or equal to. Okay? Now, let's try this one. I want you to see how we could do it, coding it first, and then we'll come back here and we'll try it on this one as well. So let's, sorry, I've forgotten it. It was y is greater than 5x plus 10. We've done all of the hard work so far. All we need to do is change this piece right here. This was our inequality, right? Currently, we have it set up as x plus y is less than 50. I just want to change it now so that it says y is greater than 5x plus 10. So I wanted to show you this because we have to play around with it a little bit. It's slightly more complicated, but nothing else in the program changes. We need the greater than symbol this time. So I'm going to go back to operators, and I'm going to grab the greater than. And maybe we can use some of what we had before. I need the y to go first. But then I need 5 times x plus 10. So a little bit more has to happen here. And that's partly what I was worried about. I'm going to just get rid of this. Order of operations is important. So let's do the multiplying first. It needs to be 5 times x plus 10. So now I need my plus. Put the 10 there. So 5 times x, I'm going to slide that in right here. So y is greater than 5 times x plus 10. I'll take this whole piece and slide it in there. There we go. Now I've got my correct inequality written in. And I wonder if you can predict a little bit what this might look like. Y is greater than 5 times x plus 10. I'm going to jump back because maybe it's easier to see it here. Y is greater than 5x plus 10. This should look really familiar in terms of lines for us, right? I mean, we're more used to seeing it like this. Y equals 5x plus 10. But I think we know what the 5 means and we know what the 10 means, right? The 10's our y-intercept. The 5 is our slope or our rate of change. That's telling us how fast the line's growing. So we know what it would look like if it was a line. What does it look like as an inequality now that I put that greater than symbol there? Let's try running it again. Lots of random points coming on. But you can definitely see that there's a section missing, right? Over here to the right, there's no points here at all. Lots of points here. But as we get more and more dots appearing, we're hoping that we can sort of see that line appear. And it just depends how long we want to play around with it, letting the program run. We're getting closer now, though, I think. Can you see that? You sort of see the line being generated here. Oh, there's one that came over a little bit further. Closer and closer and closer to getting that line. So this is kind of neat that we're actually able to program basically what Desmos is doing, right? We've created a program that's going to basically do exactly what this is going to do for us. It's kind of neat because it means you're sort of seeing a bit of the background of how it works. Now, honestly, Desmos doesn't create infinite points to make this work. What Desmos does is it graphs the line. We can do that first, actually, if you like. Here's the line. You can see it. And then it's going to test to see which side of the line actually gives us a number that works as y being greater than 5x plus 10. So for example, if we picked a number over here, let's say we tried the point 50 and 50, and we would check to see if that really does satisfy the equation. So y would be 50 and x would be 50. 5 times 50 is 250, plus 10 is 260. So is 50 bigger than 260? Nope, it's not. So this point here doesn't satisfy the inequality. That means that everything on this side of the line isn't going to work. Everything on the other side of the line does. So they do test points and they can check to see which side of the line works. And then we're all set. That's what our graph looks like. Again, notice the dashed line. If I go ahead and put an equal sign in, we've got the solid line. So that's an important part in terms of the graphing. The solid line indicates that the line is part of the solution. You really could have a point on the line, whereas the dashed line means you can't. And again, there's our program, still working away. So that gives you the basics of how an inequality works. The key to the whole thing is knowing what the line looks like in the first place. If you know what the line looks like, then we can check a test point on either side to see which side we should be shading in. but it's a little bit more fun to play around with some of these on Scratch. I've made a few that I think maybe you should try. We've done all the hard parts, so don't erase this. But here's a few that I think you should try to type in and let it run so you can see what it looks like. All you're going to need to change is this piece right here. I'm going to slide this over. Here are a few new inequalities for you to try. These first two are pretty similar to the ones that we just did. Not too much difference there. These last two, these ones are maybe a little bit trickier. You have to use slightly different blocks in your code, especially for this last one. But you're going to get a pretty neat shaped inequality when you make it. So I don't want to give it away. I'm not going to do it. You guys give this a try. It would be more fun for you to try it in Scratch first. So if you can, see if you can make it here. And once you've done that, then go ahead into Desmos and type it in there and see if it matches. But I think you'll have more fun watching it be created in Scratch first. That wraps up what we wanted to cover today. We did a little bit of inequalities and some coding at the same time. I hope it made sense. I hope it helped. And thanks, everybody. Take care.